Sorry, I just realized my microphone was off. If you have any questions, fire away. I just said that earlier today at the noon time, we had more participants for the second semester class. So you guys have my attention. So whatever you need, ask away. Okay. So Bridget, with reconstitutions, so let me just, the packet, as far as I understand reconstitutions, that would be similar to questions 21 and 22 in your packet. Did you have any, did you try those questions? Yeah, the 130 packet. Did you try those questions? And they were pretty straightforward, right? Oh, unsuccessful. Okay, that's fine. All right, let me help you out then. Not a problem. So most likely what happened in that question is that you tried to factor in the milliliters diluent added into your question. And so I'll help you out with that. So question 21 is a good starter, and then we'll jump to question 22 after that. So question 21 just says to that you're ordered 60 milligrams of a drug, and then you need to calculate the milliliters given the reconstitutions that are there. And for Allegheny campus, I thought it was important to indicate which was the or to which concentration to use, because technically you can use any of them. I guess it would just be dependent on what you're supposed to use. I indicated using the strongest concentration because you'd give the least amount of milliliters doing that. So when you look at the list on question 21, it says 5 milligrams per milliliter, 10 milligrams per milliliter, and then 20 milligrams per milliliter. The 20 milligrams per milliliter is the stronger concentration. It's the strongest concentration of those listed. And you basically see that on the label, on the drug label itself. It would basically tell you how to arrive at the stronger concentrations. And then I'll address that a little bit more in question 22. But with question 21, you would just take the order, which was the 60 milligrams, and then divide it by what you have, which is the 20 milligrams times the 1 milliliter, and you'll get 3 milliliters as your answer. Now, in question 22, when you see this, and you'll actually see this on like the vial, or at least the medication itself on the label, where it says milliliters diluent added. For math, we don't care about that. We could just eliminate that question, eliminate that that category, because that just tells you, the nurse, or most likely the pharmacy, how much deionized water to add to the powder to get to the concentration listed on the table on the right, which is the units per milliliter solution. So like if you've ever had, if you have kids and you remember giving them like an oral antibiotic, or if you remember taking that yourself, as adults, we typically get the encapsulated form of antibiotics or tablets. We don't usually get the reconstitutions, but basically all reconstitution means is that the pharmacy has it in stock as a powder, you add water, and now it's a liquid that will be in a concentration based in either units per milliliter, milligrams per milliliter, or whatever the case may be. So to answer question number 22, for the Pfizer pen, you just take the 750,000 units and you divide that by the 1 million units, because that's the most concentrated dose per milliliter, and then you get your 0.75 milliliter. And I always say, because you will have you'll have a calculator with you. A simple thing to do when you have all these zeros is find four zeros, eliminate them. 75 divided by 100 is much easier to type into your dollar store 10 key calculator that the nursing department is going to provide you. So does that help? Okay. Yeah. Now Bridget, I've worked with, I was at Boyce several years ago, and they were asking me about reconstitution questions, but they didn't have any samples to go off of. So I couldn't really answer that question directly, but I have a feeling that what was happening was they were trying to factor in the milliliters diluent added with their in their math, and you don't need that information. You just need to know what the concentration is. And a lot of times the concentration is also told to you in the same row in the thing, saying add this amount to get to this concentration. So that's half the game. Yep, figuring out what's extra and what to ignore. A lot of times, like with flow rates, a lot of times you don't really care about the concentration, you don't care about the strength, you just care about how quick you're going to deliver it. So the way I always say this, imagine we were in regular times and you can go out and have some margaritas. You can get virgin margaritas or you can get regular margaritas. Either way, they're going to be flowing at a particular rate, meaning you're going to fill up your glass, maybe 2 glasses per hour or whatever it is, that you're going to be doing that. But it doesn't matter if it's virgin or, super strong. I mean, it might matter to you as far as your goals for getting a buzz, but it's not going to matter how quickly you drink it, because that would be more, or it doesn't matter the strength or if there's alcohol in it or not, because it's all based on the rate. If I asked you how many drinks did you have per hour, as opposed to was it alcoholic or non-alcoholic. I hope that made sense. I feel like I just had margaritas and then tried to explain that. So. All right, so I see Amanda in here and Julianne. If you have any questions from the 130 packet, just you could type them into the chat, or you can just you could turn on your mic. Um, Bridget, when my mic was a little bit cutting in and out last time, I actually added my microphone, and then also I think my computer was going through an update, which was probably pulling from the resources. So if you guys have any questions, just type them in, or unmute and ask away. I can do number 24. Okay. So this is a weight-based equation. Let's make sure I have the right packet. This is a weight-based equation that basically is something you'll get into in third semester, more so with the pediatric dosage calculations. So this is how you do this. So you always start off with, anytime you have a patient's weight in pounds, you need to convert that to kilograms. So question 24 says you have a patient that's 176 pounds, and then what is that in kilograms? 80 kilograms. All right. Now it says you're going to calculate the loading dose. Now, someone asked about this question earlier, actually, and they asked about the 300 milligrams. That's just the maintenance. They're just telling you to give them 300 milligrams per day after you do the loading dose. For this question, you just need to be able to answer the loading dose. So you just take that 80 kilograms times the 15 milligrams per kilogram. You could see those eliminate, and then 80 times 15 is your answer. Yep. Ignore the 300. Like you said earlier, the things that to not pay attention to. That just tells you, that's just giving you the whole profile. So like, I don't know if you've ever taken a Z-Pack before or known somebody who's done a Z-Pack, or even there's like, I think the prednisone pack is the same way. It'll tell you to do like, 4 one day, 3 the next day, 2, then 1, and then you kind of like, there's a different dosage each day. It's the same concept. So basically, this question is just telling you what the order is. It's do the loading dose first, then do the maintenance doses after that until they either run out or until they're done doing this, whatever this protocol is for their seizures. So yeah, for this question, to answer it from a math standpoint, ignore the 300. As a nurse, you would want to know that information, because after the loading dose, you would be giving them the 300 milligrams daily, assuming that's part of your protocol. Okay. Yep, absolutely. All right. So the trick with flow rates is just remembering that your flow rates are going to be in milliliters per hour. So that might just mean you need to do a little extra conversion. So for 17, we have 120 milliliters, 90 minutes, and we just need to convert minutes to hours. And I think the answer to this one is 80 milliliters per hour. A variation of this type of this question here is you might see something similar, but instead it's like 120 milliliters, and let's say in 30 minutes, and you would do the same thing. You would still count and convert minutes to hours. The thing that sometimes people have a problem with this is it ends up being 240 milliliters per hour. And that seems like a high flow rate when you're like, well, I'm only going to give them 120 milliliters in 30 minutes. You're right. We're going to turn off the infusion pump once it's done, but we need to know what to plug into the infusion pump. And that's where the 240 comes in. So It's just how fast is it pouring, essentially. Yes. Okay. So 23 you probably already know how to do because it's just the combination of two things that you've done in previous questions. You're just going to calculate how many milliliters of Vistaril plus, and then you're going to add how many milliliters of meperidine to give to the patient. So for this question, for the Vistaril, we're going to start with 60 milligrams. And the available is 50 milligrams per milliliter. And I'm just going to indicate that that's Vistaril. For the meperidine, the order is 85 milligrams, and we have 75 per milliliter. And then if you tell me what 60 over 50 is, I think it's 1.1. Oh, 1.2, thank you. And then I believe that the meperidine is the 1.13333. And what we would do here is just round to the nearest tenth. So we could just eliminate all those extra threes. And then we just combine these two to make 2.3 milliliters. Yeah, a lot of times it's just the way that the question is worded. It may, you second guess what you're supposed to do. But I can almost assure that most everyone who takes these tests, they know exactly what to do. It's just they get that math anxiety, and yeah. No. So for the concentrations, um, that is actually not true, because you would actually get different amounts to inject. So let's put it in these terms. If it was 0.75 for the 1 million units per milliliter, you would actually need double that, 1.5 milliliters, if you use the 500,000 units per milliliter solution. So you would actually need more volume, but the dose would still be exactly the same. You'd still be giving them the same dose. It's just that how much you would administer would differ. That's the thing you have to pay attention to. Like when they ask the question, they have to ask the question if they're looking for a specific answer. So in reality, you could have three separate answers to question 22, and all three be correct depending on which concentration you utilized. I added in the question to use the strongest concentration, but in reality, I don't know specifically which concentration you're supposed to use. If you're always supposed to use the strongest, or my guess is you would use what was available, and so that might vary from solution to solution. So. Yeah, and I'm sorry I don't have a better answer for that, but that's kind of where I've been stuck, because I've actually posted that or posed that question before, and I haven't really gotten much, or actually haven't gotten any feedback on it. So I don't know how to help out with that. And I haven't seen any good sample questions on reconstitution with what's it called? With like the NCLEX and stuff. So I don't even have a good, the good like thing to work off of to tell you like, oh, this is how they answered this question. So. Yeah, on you're talking about like replacement volumes in and out. I think that's what INO stands for. Input and output. Yeah. So if you look at question 6 in the 130 packet, is that what you're talking about? Yeah. So those come in a variety of things, and what I usually do is I just manipulate what volumes there are. Um, Yeah, I imagine yours, you probably have the one where you have to also account for like if they had Jello or if they had, you know, juice versus just water. Yeah, so I don't have any specific samples that include all the ins and outs, but here's what you would look for. You would look for, like on question 6, I keep it very, very simple. I would say you start off with what was their output first. So I would say, okay, their output was 500 milliliters. And then I'll just indicate that that was the output. Then I would put that over whatever their input was. So if you know that their input, I'm sorry, you would put that over the original, or where it says for every 125 milliliters, the replacement volume, you would put that down here in your denominator, which basically just would tell you that for every 125 milliliters, and then if the actual was 500, that's what you're accounting for. And then you would just multiply by the replacement volume. So replacement volume is 40. Now, and that's your 40 in, not milligrams, sorry, liters. Your 40 milliliters in, and that would actually give you your replacement volume. Um, I guess the way that they would add this is you really just need to worry about your output and then how much you're replacing with. So like, let's say they had a whole bunch of stuff, but they only voided out 500 milliliters. It's all you really need to worry about. And then you just make this comparison. So I would need to see an example of that question, and then I can help to chop it up a little bit better. Because obviously the way that we do it at the Allegheny campus is just very simple and straightforward. Um, uh, so if you have an example of that, I'll be happy to work it out for you a little bit better. And then just to answer your previous question, I did work something out like this on YouTube. I may have worked it out a little bit differently, but the concept's the same. And like I said, if you find like a sample question, because in reality, it probably, because you're basic, this is based off of infusion, and really you're just concerned about kidney function and making sure that you're getting adequate blood flow to the kidneys. So in reality, you just need to make sure you're giving them enough, because if they're consuming 1,000 milliliters, in an hour, but they're only voiding out 200 milliliters, then your replacement would be much lower than what is requested, and hopefully they're peeing out more than what is listed here. So otherwise, you're dealing with a patient going into shock. Okay, you got it. I'll type it in here real quick. So if you just do a search for you on YouTube, just look for Dr. Rad, the Rad Tutor. You'll see my picture, like the picture you see associated with my chat or with my Zoom. Wearing a blue shirt, collared shirt with a tie, and then you'll see the videos right on there. And if you can't find it, just let me know, and I'd be happy to. You can email me as well. And then I'll probably post these on YouTube as well, just as additional, uh, just an easier place. You're welcome. An easier place to find where these things are. So, okay. Okay, that's perfectly fine, Bridget. Yeah, so I imagine I'll answer that question again. Oh, and if you go on the YouTube, I answered an alternative using a different patient weight, and I'm sure, and if you bring it up, everyone appreciates. I mean, maybe they do, maybe they don't. I don't know, but everyone appreciates like going through that heparin protocol, just using a different patient's weight. So just let me know, and I'd be happy to. I mean, if you want to come up with a different weight, I'll work through it and show you how it's similar. Yep, sounds good. Juliana, do you have any other questions? Okay, yep, perfectly fine. You're welcome. And also, I'm doing the 1:30 class again on Thursday at noon, and then again at 3:45. So, any questions? Otherwise, yeah, go ahead and email me. So, well, if I don't hear from you, good luck. I hope you do well on your test next week. You're welcome.